Hey guys, I'm back with a new video. In this video, let us learn about a very important topic, and that is ensembling. Many a times what happens is that individual models that we create do not perform very well. So no matter how well you tune the hyperparameters of your model, so if you have the case where your individual models are not performing above a threshold value, then in that kind of scenario, you can use something called as ensembling. So in this video, let us first understand what is ensembling. So to understand the concept of ensembling, let us take an example. Let us say we have a couple of models with us, say model M1, model M2, model M3. So what we do in case of ensembling is that we combine these multiple models to build up a new model. So this is our model M1. We combine this with model M2. And we combine these two models with the third model, say model M3. And in general, you can have any number of models, so say N, okay? So you can have model N as well. So you can say ensembling is kind of merging or combining multiple working models, which are kind of say weak models. So this is a weak model, say. This is also a weak one, yet another weak model. And we combine these weak models to build, say, a strong model, right? So we are combining these multiple weak models to form a model, or you can say as a result of this merging process of these weak models, we get a new model which outperforms the constituent models that got in the merging process. So here we are basically merging these weak models to create a new model which outperforms the constituent models individually, right? So this resultant model that we get is better than these constituent models. So let us say the new model that we got as a result of this combination is model M4, right? So it is better than these constituent models. The models that we used in the ensembling process are called as the base models. So let me write this down. Base models, models that we use in ensembling, right? Now let us move forward and understand the ensembling techniques. So we will basically be discussing two ensembling techniques. First one is the voting based technique. So voting based technique. And the second one is called as stacking. Now let us first understand the concept of voting based technique. So let me clear this up. Voting based technique. Now this concept is basically used in problems pertaining to classification, which I will be explaining in this video in a few minutes. Let us say we have four different base models. So base model 1, base model 2, base model 3 and base model 4. So we have these four different base models and we applied each of these four models on a data set, say D1. Let us label each of our four different base models by BM1. So these are our four base models. So four base models, and this is our data set. So let us say our first model is a logistic regression model. So logistic regression. Next, let us say our model BM2 is a support vector machine classifier model. So you can say SVM model. Next, let us say that our BM3, which is a base model 3, is a decision tree model, DT. And finally, let us say that our model 4 is a naive Bayes classification model. Now another way could be to use a single model instead of these four different Bayes models and make four splits of our original dataset. So this is our first way, can be. So the second way could be to use a single model, so Bayes model, instead of these four different Bayes models and make four splits of our original dataset D1. So let us label the four splits of our original dataset as D11, D12, D13, D14. So what we are doing is this entire dataset D1 is getting splitted into four parts: D11, D12, D13 and D14. So in the first way we are using four different base models and a single dataset, and in the second way we are using a single base model, and instead of using the original dataset we are taking four splits of that original dataset, right? And for this second way, let us say here we are using the logistic regression model, and we are using the logistical regression to train these 4 parts of the dataset: D11, D12, D13 and D14, right? So here also we are using 4 different base models, but each of them is a logistic regression model that works on each of these 4 splits of the dataset. But contrary to the first way, here each of our 4 base models is a logistic regression model, right? So now we have our 4 different base models using one of the ways that I just mentioned. Let us now understand voting based technique in case of classification. So let me clear the canvas first. So we have our 4 models: base model 1, base model 2, base model 3 and base model 4. So the first technique that we have in voting in case of classification is majority voting. Majority voting. Let us say we have a binary classification problem 0, 1 and we have our 4 different base models. So let us say the prediction in case of model BM1 was 1. In case of model 2, say it was 0. So BM2 0. In case of BM3, let us say it was 1. In case of BM4, let us say it was also 1. So here you can see that 3 of our 4 base models predicted the output as 1 for the binary classification problem, while model BM2 predicted the value as 0. So for this case, if we apply the majority voting concept, we can see that 1 is the clear winner, which means that the final prediction is 1 by the concept of majority, right? Because 3 of our base models are voting for 1, while the second model, which is BM2, is voting for 0. So by majority, the final prediction is 1, right? Next, let us see what other technique do we have for voting. So the other technique that we have for voting is called as weighted voting. Weighted voting. So in this technique also, let us take our 4 different base models: BM1, BM2, BM3 and BM4. But here we also need to take some weight into account for each of our 4 different base models. So let us say we have our 4 base models, and then let us say for each of our base models we have the weights W1, W2, W3 and W4. Let us say the weights for each of these models starting from BM1 and going till BM4 are 1, 2, 1 and 3 respectively. And let us consider the predictions by each of these models as 1. So predictions 1, 0, 1 and 1. So now in this case, we will not just count the number of 1s and the number of 0s as we did in case of majority voting. Here we will also consider the weights. These weights basically tell us how much important our base model is. So according to the weights that we have assigned, the BM4 base model is the most important model because it has a weight of 3, right? Now here we also need to take into account the weights so as to see how many times a particular prediction has occurred. So for prediction value 1, the number of times prediction 1 has occurred is 3, right? So 1, 2 and 3. So let me write this down. Number of times we get 1 as the prediction, 3, right? Now let us see how many times 0 has occurred. So the number of times 0 has occurred is 1. Now since the number of 1s are more than number of 0s, so by the concept of weighted voting, therefore the final prediction will be 1, right? So here you can see that using weighted voting, we can actually give weights to our models, and we can specify that the model that has a higher weight than other models is more important than other models. So these are the 2 ways using which we can actually perform voting for our classification problem. Now let us see the concept of averaging that comes in case of regression. So let me clear the canvas first. So the topic is averaging. So for averaging, let us consider again our 4 different base models: BM1, BM2, BM3, BM4. And since this is a regression problem, let us consider the outputs that we get from our 4 different base models as y1, y2, y3 and y4 respectively. Remember, in case of regression, the output that you get from regression models are continuous and not discrete. Here also we have to consider weights, but here in this case our weights would be kind of in decimals, or you can say as fractions. So let us take the weights of our 4 base regression models. So weights, let us say for the base model 1, the weight is 0.1. For the second one, let us take it as 0.2, then 0.1 and 0.3, right? Now your final prediction will be something like this. So with simple averaging we get, using simple averaging, what we will do here is that we take the output and the weight for each of our base models, we multiply them and then add them together. So for base model 1, we will say y1, which is the output, multiply it with the weight of the base model 1, which is 0.1. Then let us do the same thing for each of our base models. So for BM2 it will be y2 into 0.2, y3 into 0.1 and y4 into 0.3, and we divide this by 4, right? Because we are having 4 base models. Next, let us talk about the stacking technique. So let me clear the canvas. Stacking. Now here in stacking, models are actually merged using another machine learning model on top of it. Merging models using another machine learning model on top of it, right? So consider a scenario where we have a dataset that we use with different models. So say we have this dataset D1 and we are using it for training in case of some model, say M1. Let us say we are also using the same dataset for training our models M2 and M3 as well. Now once you have used this dataset D1 to actually train each of your 3 models M1, M2 and M3, what you will get are the outputs from each of these 3 models. Now the interesting thing here is that each of the 3 outputs that we get from these 3 machine learning models, we will use them as inputs to another machine learning model, say M4. So these 3 outputs O1, O2, O3 are inputted to this model M4, and this model M4 will then give us the final prediction, right? Say O4. So this is our final machine learning model, right? So stacking of different models to form a new machine learning model can be done in different ways too. Now as a side note, in case of voting and averaging, we don't get a new machine learning output, but just a prediction taking into account all the base models that we use. But here in this case of stacking, we get a new machine learning model, right? So this was all I wanted to cover in this video. If you liked the video, do give it a thumbs up or comment down below if you have any query. Don't forget to subscribe to the channel, and I will see you guys in the very next one.